Alright, welcome back everybody. Today we're going to be covering tires, wheels and tires, and we're going to start off with things that we need to do a tire inspection, inspecting the tread, measuring the tread depth, checking tire pressures, making sure that they're at the recommended tire pressure. Then we're going to get into some of the service side of tires. As far as tire rotation, we're going to show you how to remove and install a wheel correctly, what tools you need to do that as well. But first, let's start with tire inspection. Some of the basic things that we're always going to need when we're inspecting tires. We can start off with a pressure gauge. This is just our standard mechanical type. Everyone should have one of these in your glove box. That way you can get an accurate pressure reading from your tires at any time. The next tool we have down here, the way these work is we just put them on the valve stem, and the pressure in the tire is going to push the gauge outward, and on here we have our different pressure readings. So wherever it lines up with the bottom of our gauge is what our pressure reading is. For example, this would be 26 psi. Make sure we're reading the psi side of our gauges. That is our standard system. Our other is kilopascals here. Okay, pretty straightforward on that one. The next one we have here is our tire tread depth gauge. Okay, the job of the tread depth gauge is to measure the depth of the groove in our tread. Department of Transportation says the minimum tread depth legally allowed before you have to replace your tires is 2/32 of an inch. 2/32 of an inch. So you can see right there our tread depth gauge switches to red at 2/32. Okay, and we'll demonstrate how to take tread depth readings, but this is going to show you how much life you have left in your tire tread. How close are you to needing to replace them? Over here we've got tire inflation, and these are tire inflation tools and pressure gauges all in one. So this is the newer digital style. These are the most accurate. What's nice about this, we can get a reading and adjust tire pressure all in one. So this is going to hook up to our shop compressed air to do that. This is the older, one of the different mechanical styles. Same tool, but the gauge will pop out of here just like our other mechanical tool and tell us what the tire pressure is, and we can use this to also inflate the tires as well. Okay, next set of tools that I have in front of you here, these are a lot of the common tools that we use to remove and reinstall wheels correctly. So if we're doing a tire rotation, that's definitely something we're going to have to do. A lot of procedures on a vehicle start with removing a wheel and finish with reinstalling it. So it's a very common procedure, and if we are going to be taking wheels off of vehicles, they must be reinstalled correctly using the star pattern and torqued to the proper specifications. So we're going to show you all those tools. There is a couple different ways we can remove and install a wheel depending on if you're in a shop or the side of the road. We do have some tools for removing lug nuts manually, like our old tire iron here, a breaker bar. But we also do have some power tools here that we commonly use to remove lug nuts as well. But to start it off, breaker bar is kind of what we've moved to break lug nuts loose by hand. This is a 1/2-inch drive breaker bar. They're very strong. Usually we're going to attach what we call a flip socket, lug nut socket set. So we're going to grab these sockets are double-sided, and they are the common lug nut sizes. So what's nice about this is you can grab this kit, grab a breaker bar, and you know you have everything that you need to get a wheel off of a vehicle. The way the flip sockets work is we find which side of the socket fits the lug nut the best, and then we take the extension and place it in the other side of the socket. So if I was going to use this side on the vehicle, take my extension, goes in the back, and now I can put this on my breaker bar. Hey, remember we're going 1/2-inch drive because lug nuts can be a pretty high torque, 80 foot-pounds, 120 foot-pounds, sometimes a little higher than that if it's a heavy-duty vehicle. So we need some big tools that are going to be able to handle breaking those big lug nuts loose. So 1/2-inch drive tools. Let's look at some of our power tools over here. In the past we used a lot of I have a tire iron off to the side over here. This was kind of our old school tool we used to use to break lug nuts loose by hand. but these different sizes around the outside have now kind of been replaced by the breaker bar with the flip socket set. So we don't see these too much anymore. Besides removing lug nuts manually when we're in a shop, a lot of times we are going to be using power tools to help make that speed up that process and make it easier on us. Power tools we have in front of us, we have a couple different air tools, pneumatic tools. This is a 1/2-inch drive pneumatic impact, commonly used to remove lug nuts. This is the strongest impact gun that we have in the shop, strongest power tool. Downside to our air tools, if you remember from our tool lesson, they're heavy. We have to attach an air hose, so we have to be somewhat in reach of the shop air system. But we still do use those. They're strong and they're quick. Air tools have gotten smaller. You can see this one. This is one of our newer tools we won. This is like a little noisy cricket here, but this guy has a lot of torque in it for its smaller compact size. But if we are going to move that way, electric tools are getting better and better and better. So this is kind of the way that the industry is moving. Electric power tools, they're wireless, cordless. They have a lot of strength now. They're not as noisy. So this is a common one that we're using a lot. Other big benefit is I can take this with me anywhere. So in the past here at the school, if we've had a teacher's vehicle that's stuck somewhere, we can take this power tool with a flip socket set and use it away from the shop. So electric power tools are a convenience. A couple other things that you see down here. Ways that we need to finish installing a wheel. We're going to torque those lug nuts to a very exact specification. We're going to look that up in our owner's manual, on our service program, but we're going to find that torque specification before we finish tightening that wheel. We're going to use a torque wrench. This is also a 1/2-inch drive, so we're sticking with the same drive size. And torque wrenches are used to set a certain torque amount. This is the foot-pound gauge. I'm not sure if you can see it very well. But if, say, our Honda Civic needed 80 foot-pounds of torque, I would adjust this torque wrench up to 80 foot-pounds. And then I would go around the vehicle, tighten all the lug nuts, and when they reach 80 foot-pounds, it will give me a click. Okay, so this is what we are always going to use to finish installing lug nuts. Make sure that they're at the proper specification and that they're tight. And we're going to do all of that in a star pattern that we will discuss a little later. I do have these off to the side. These are called torque limiting sticks. I do have these off to the side. These are called torque limiting adapters. These are all different gauges and sizes, whether it's the socket or the amount of torque that they're going to allow be applied to the lug nut. But the idea behind these is if we had a 21 millimeter lug nut that needed to be 80 foot-pounds, we would use this torque stick or torque adapter. It's a 21 millimeter socket, and the stem of this, the neck of this torque stick, is designed to start to deflect or twist above 80 foot-pounds. So these are a quick way to put these on a power tool, run your lug nuts down with a power tool, and they will generally be the right amount of torque and the equal amount of torque. We don't particularly personally like to use these because we're relying on power tools to do the work. So say our battery might be not fully charged, not completely charged. So for example, if our battery was not completely charged, and we use the torque stick for our final lug tightening, we might run into some under torquing issues. So the best guarantee is to always torque your wheels with a mechanical torque wrench as our final step. So first things first, if we're going to take a pressure reading of the tire, I'm going to grab my mechanical gauge, find the valve stem, which in this case is right here. I'm going to place it all the way over the valve stem and get it to make sure that there are no leaks. Okay, I don't want to hear any leaks, and once it's sealed on top like that, I can see the gauge has popped out. We know we have a good pressure reading. Okay, you can take it off the valve stem, take a look at our reading. In this case, on this tire, we are looking at 25 psi. Okay, so now we would go on the vehicle, find out what the tire specifications are. What should this tire be inflated to? Sometimes they can differ front to rear, and adjust as necessary. Okay, so we finished measuring the pressure with our mechanical gauge. For this example, we'll use 32 psi. This tire is going to be 7 psi low. We're now going to use an inflation tool to put compressed air into the tire and raise the pressure. I'll go ahead and hook this up. I'll also show you how you can get a pressure reading with these as well. Power it on, make sure I'm in the PSI setting. And then same procedure as before, I'm going to get this over the valve stem so it seals tight, no leaks. And our gauge is reading 23.5, so it's a little bit more accurate than our mechanical gauge. I'm going to go ahead and take this up to 32 psi is what we said our proper pressure for this tire should be. So I'm going to pull the trigger. We can hear air start going into the tire. Let off to check again. 27. Okay, 32. If you do go over, there's always a way to let air out of the tire. In this case, you pull the trigger a little bit and you can vent air and deep pressure and deflate the tire. 32. Okay, now let's measure tread depth. We're going to take our tread depth gauge, which is just a plunger that we're going to push down into the tread groove and see how deep or what the depth of that tread is. And then we're going to use the collar to get a reading. And so if I go to my tire, we want to measure inside and outside tread. It's good to measure all of them and see if we have any variation or conicity. Is the tire wearing unevenly? Might lead to some alignment issues or other things that possibly need to be corrected. But to get a tread depth reading, I'm going to take this gray bridge and kind of put it across our tread groove, just like so. And then I'm going to push the plunger until it touches the bottom of the tire. And then I'm going to push the plunger until it bottoms out in the bottom of that tread depth groove. Now if I look on my gauge, I find the line that lines up the best to our collar. In this case, it's going to be 9/30 seconds. Okay, you can see 10 has a little bit of a space. 8 is covered up. So 9/30 seconds of tread left on this tire. That's well within the green. Remember that our minimum specification for tread depth is 30 seconds. So this tire still has a pretty good amount of life left. Okay, so we measured our tread depth. We've got our pressure readings for all 4 tires. How do we know what to set the tires at, or what to inflate them to? Where we're going to go to look for that is usually in the driver's door jamb. You're going to see this tire loading info placard or sticker. And this is a great place to go to get our information for what our tires should be set at. We have our tire sizes right here, so you can see we have front, rear, and spare. The tire sizes for the front and the rear are P215s, 55R17s. Okay, and we'll go through the tire size and explain to you what each of those numbers represents. Okay, next to that, in the third column over, we've got our pressure ratings for each of those. Okay, so you can see for this vehicle in the front, we should be at 33 psi. We should have the same pressure in the rear, and our spare tire is going to be at 60 psi. Other information that you can get off of this, total number of seats in the vehicle, load information, and that's usually found right next to our VIN number placard. So driver's door jamb. Great location for tire specifications. Other places that we can find our pressure rating, there is a maximum pressure specification on the tire, but that is the maximum. So for these tires, they probably say 44 psi max, but for this vehicle, Kia wants us to run those at 33 psi. Another place we can go for our tire specifications is on our shop service information software. So we can also look all of that information up on our computers. Okay, we're this part of the tire that has our tread patterns, our grooves, all the things that help us maintain traction with the road. This is the tread area of the tire. Okay, and that usually goes between here and here. Depending on the tread pattern, that can be a little more pronounced. On this tire, the tread pattern would be between here and here. So this is the tread of the tire. Okay. Other parts that we have, this is the sidewall of the tire from here to here. And this is the structural part of the tire, meaning it's actually what's supporting the weight of the vehicle. So one big major rule with tires is if you have a puncture, we can repair those with a patch. But we're only allowed to patch tires in the tread area, okay, so between my two fingers. If we have a puncture or a slice or damage to the tire on the shoulder or the sidewall, we are not allowed to repair the tire there. It needs to be replaced. Okay, so sidewall, tread area, and then the shoulder. That's where it rolls over. The bead of the tire is where our tire actually seals to the wheel. Okay, that bead actually snaps into place. And there is a metal cord in there, cable. There's like a hoop inside the rubber. The bead that we were talking about, this inner cable that snaps into place and seals against the wheel, you can kind of see that right there, down the cross section of that. So some other things that we can see, you can see our nylon cords there, those white dots across the top. Okay, we do have steel cables in here as well. That top layer above the white dots is our steel cables. So nylon fibers, cables, and our rubber plies, kind of the different layers that make up our tire. And don't forget about our bead as well.